Okay, Andy.
Good to go.
Yes. Okay, this is the webinar on using the photorealistic rendering capability in TracePro. The moderator today will be Andy Knight, and I'll be your presenter. I'm Michael Gobbin, Vice President of Sales for Lambda Research Corporation. This will be a 25 to 30-minute presentation, followed by a question and answer session. Please submit your questions anytime using the question box in the GoToWebinar control panel, as you can see over here on the right. We have additional resources for you. If you're interested in past webinars, please find the link below. The TracePro tutorial videos are available, as well as TracePro tutorials and information on our upcoming TracePro training classes. The current TracePro release is TracePro 7.3.9, and it was released December 11th of this year. TracePro 7.4, which has the photorealistic rendering, is now in early access. We're expecting to release this before December 22nd, so in the next week. This release can be downloaded by anyone with a current maintenance and support agreement, and of course from our website at lambdares.com. Today's webinar topics are very simple. The rendering is actually a very simple setup. First of all, you're going to set up the eye and target positions for the render. You can use both ambient light sources and TracePro user-defined sources. I'm going to go through the photorealistic render calculations and how we do the photorealistic render and how it gets set up and what the several passes mean. I'm going to show a couple of examples on luminaires, light pipes, and LED examples. I'm going to show you the best methods to get good results. And finally, I'm going to have problem resolution tips for you. So let's get into using the photorealistic rendering capability in TracePro. Let's look at the basics. First of all, you want to check out your photorealistic rendering view. If it's too big, it's going to take a long time. So to start off, you want to set a very small system view. The reason why we're going to use a small system view is because this sets the number of rays needed for the render. The larger the view, the more rays you're going to need. So a smaller view correlates to a much faster render. There are rendering quality settings. There are 5 of them. The number of rays for each rendering pass for each higher setting correlates to 10 times more rays being traced for each higher setting. So you're going to see that we have 5 of them, and each one is going to take 10 times longer to ray trace. After you render the view, you can set the brightness and contrast to increase or lower the intensity of the image for better results, and use contrast to be able to see things more clearly. And you can do this all after the render is done, so you don't have to worry about this, and you can post-process this type of operation. Well, let's look up the setup first, and that's underneath a new area underneath the View menu. If you go to the View menu in 7.4, you can see that about halfway down, you're going to find photorealistic rendering, and there are going to be 3 options: Setup, Render, and photorealistic rendering options. If we start looking into the rendering setup, we have 3 options on the menu itself. First of all, we're able to set up ambient luminance sources like outdoor, office, and custom settings to have them be ambient settings and to emit from above or around your particular system. So for instance, selecting the outdoor source specifies a 30,000 candela per meter squared source, so pretty much the sun, quite bright. The office selection is like a 100-watt bulb. You're getting a 100 candela per meter squared source. These ambient luminance sources don't have to be set up in your model. They're set up here in the photorealistic rendering menu. And they specify a hemispherical white light source emitting from the direction selected in the dialog. So for instance, when you specify a specific direction of y equal to 1 here, this means that you have a hemispherical source positioned in the positive y direction, shining downward. The custom setting allows you to define the luminance level to whatever you want. So this is pretty much open to how you want to set up ambient sources all around your system. If you want more than one, I'm going to show you a technique for doing that as well. Let's look at the next setup. The next setup we're talking about is the rendering quality. There are 5 different options and settings here: low, medium, high, extra high, and extremely high. Each higher setting sets the number of rays 10 times higher than the previous setting. The number of rays for low resolution rendering is 10 rays per pixel. Therefore, 10x would be the medium rating, and this is 100 rays per pixel, with 10x more for each higher setting. So it's possible to trace a huge number of rays, but please also note this correlates to a much longer ray tracing speed and time as well. So we're talking many, many hours for that extremely high setting. In fact, we might be talking days. So the first thing that you want to set up is your view. There are 2 ways to do this. The View Set View menu is the dialog to check to verify the eye and target positions for your render. Or you can just set up the system view the way that you want it right from your system view area. So when you bring up the Set View area, how do you get there first of all? Well, of course, it's from the View menu, and you just slide about 2/3 of the way down, and you'll see a Set View option. You go in there, and you'll see 1/3 of the screen specify an eye position in X, Y, and Z. So this will be where you want to specify your eye. The target position is where you would usually set up the exit port of your light pipe or the area that you want to see in a luminaire or an LED. And the up vector orients the system view, which says, from the eye position to the target position, what up vector, in what direction do you want to have the up scenario. So this is all easily set up, and you can have both perspective view and non-perspective view. Once you hit that apply, that then sets the view. You can, of course, tweak the view afterwards using all of the interactive X, Y, Y, Z type views, but you can also set up a custom view by translating and rotating into the position that you want to. If you want to know how we set this all up and what's the underlying basics, the Wikipedia has an excellent article on this, which discusses photon mapping capability as we have implemented it into TracePro. I'm providing the link here, but pretty much what we're looking at is that there are 2 passes for a photorealistic render. First of all, we do forward ray tracing, and we construct a photon map. With photon mapping, light packets called photons are set out into the scene from the defined TracePro light sources or your defined ambient light sources. Whenever a photon intersects with a surface, the intersection point and the incoming direction are stored in a cache called the photon map. Once we've created the photon map and we've finished our photon ray tracing, we do a second pass. The second pass is reverse ray tracing. In this step, we create the photon map, we use the photon map created in the first pass, and we estimate the radiance level of every pixel of that photon map and of the output image using reverse ray tracing. For each pixel, the scene is ray traced until the closest surface of intersection is found. Now this can take quite a bit of time when you have thousands and thousands of rays being traced. So this is why it's good when you first start off to create a very small view and do a quick ray trace to see if you set up everything right before you go and create a very extreme high tight render. So this is the basics, and if you want to know more, please go to the Wikipedia page. So let's take a look at some examples. Well, the simplest example is using an ambient light source. This is where, for instance, you set up an ambient light source, say, of an office type setting, and you have it coming directly from above. So we've created a camera, and we've illuminated it from above. We've done a render. Now let's take a look at how long some of these things take. On low setting, it takes a few minutes to ray trace. We're using 10 rays per pixel. And you see the results on the left here. On the right-hand side, this is the medium setting. It took a couple of hours to ray trace, and we're tracing 100 rays per pixel. As you can see, the model on the right is much nicer than the model on the left. We have full color. We can see some ghosting in the lens itself, and we have some shininess and some matte occurring on both of these. But of course, if I were to want something for marketing or to show anyone, I would probably go with the medium setting. So probably before I left for the day or during lunch, I turn on the render and then wait to see the beautiful rendering that I'm seeing there on the right-hand side. Let's take another look. Dave Jacobson created this one. This is a TARDIS from the Doctor Who series, and we have an outdoor light shining on top of the TARDIS or the phone booth here. And so we have a TracePro defined surface source for this particular render. On the left-hand side, we see what it looks like for a low setting. This takes a few minutes. On the medium setting, we see that this takes a few hours, and it's very difficult to differentiate between the low and medium setting. Sometimes it really does help to start with the low setting and then progress to the higher setting. On the right-hand side, we can see a high setting ray trace, which took 90 hours. So this is the first 3 settings that we could possibly use. And it really doesn't make any sense to go into a extreme high or extremely high setting, because that's just going to take an awful lot of time, and I don't think there's going to be much improvement on the photorealistic render as we see right now. Of course, the one on the right does look the best. The windows look the best. It's not spotty. We have a pretty nice image there. Now, we are hoping to speed up the ray tracing in future releases, but right now this is what we have. And I'm really starting to think that a medium ray trace setting is most likely the best setting when you start doing one of these. Let's take another look at another example. Since we've been talking a lot about light pipes with photorealistic render as being a very good thing and something that almost everyone needs, we took the TracePro logo. We put it on top of a light pipe and added 2 LEDs on either side. We then let the LEDs emit. We put an eye position out in front, and we looked in a perspective view at the front where the TracePro logo is. In the low setting, which took about a minute, you can see in the top upper left the photorealistic render. In the medium setting, which took about 10 minutes, I think we got the best view here. So we're actually able to see that the TracePro logo is uniformly lit up. We went to a higher settings, which took about 4 hours to render. We see very little differentiation between the high setting and the medium setting. And for 4 hours, I don't think it's really worth it. And of course, we went to the extra high setting, and that took 40 hours. And in some cases, I think it looked a little bit even poorer than the medium setting. So once again, I think I'm going to stick with the medium setting for something like this. And the reason why is because as we trace more and more rays, that doesn't mean we're getting better resolution. It just means that we're adding a lot more rays to that particular area. And one of the things you might want to look at is different viewpoints to see if you can get a much better rendering. Why do I talk about viewpoints? Well, because a photorealistic render is dependent on the target and eye position you set up. It's very possible in a light pipe that you might not get any light out at 60 degrees from the face of the exit port of the light pipe, but you might get a whole bunch directly coming out. What is the case? Well, with a photorealistic render, you're probably going to have to do several viewpoints, and the ones that you're interested in. You probably have a specification that you're going to be using, and that specification is going to determine which photorealistic rendering eye and target positions you use. In a past webinar, we used a TracePro dual light pipe example. This had a simple LED on the left-hand side of the light pipe going into a rectangular light pipe that then had 2 output ports. As we see here, we forward ray traced in the upper left-hand corner, and we can see a couple of rays reaching the first output surface. If we do an irradiance map on that output surface, we can see light output on the upper right. Now if we do a photorealistic render of the view that you're seeing here and just look at the output face, on the left hand side in the bottom we see the photorealistic render from the low setting. To the right of it we see the medium setting. The low setting takes about 1 minute and the medium setting takes about 10 minutes. You don't see much of a correlation between the irradiance map and the photorealistic render. This is because the irradiance map takes all of the information on that face but doesn't give us the angular information for the eye and target position we have. So we have to add that information in. That's a much more difficult calculation, and this is why the photorealistic render needs two passes. We need one for forward and one for reverse, and then we need the photon mapping to bring it all together. So the output that we're seeing here looks quite poor in terms of the output face. Now if we go back to Lightpipe design itself, we know that output faces usually have textures, and the reason why they have textures is to mix the light. So what I did was, in the last step here, I put a Moltech 11005 texture, which has a very large RMS roughness, to really diffuse out the light. And I did a photorealistic render of that, and that can be seen in the bottom right-hand corner. That's much better. You can see we have light output on the whole face. We have a couple of hot spots, but really, in terms of how the light's coming out and everything else, you're seeing a much nicer uniformity coming out of it. In fact, you can even see some of these high spots in the irradiance map showing up as those green lines that are going up and down. So we know that there is some disparity here, and we also know that there's probably some angular differentiation as we come through the pipe. And what's happening here is that in the light pipe, we're creating modes because of the bends that we have in the light pipe that are funneling light out at certain angles. And because of this, this is causing the photorealistic render to look like three separate lines coming out. But when we put a very nice texture on the output, then the light gets scrambled up and we get that uniformity that we're looking for. So TracePro is showing us exactly what happens in real life, and now you can see exactly why you want to have texture on most light output faces of a light pipe. And so the photorealistic render really helps us out here understand some of the principles behind light pipe design. Well, we have a classic case that we've been using for almost, I'd say, several years for doing luminance calculations and photorealistic renders. And what we did was we went back to one of the luminance calculations that take about 10 hours. And this is just a sphere on a chessboard. And what I wanted to show was the photorealistic rendering option that allows you to set the brightness and the contrast. So we've got a chessboard with a glass sphere, and I show three different ray traces or renders. In the left-hand side, I'm showing a low setting for this particular photorealistic render. It takes about 15 minutes, 10 rays per pixel, and this is using the 50% normal brightness and contrast settings. So these are your default settings, and this is what your photorealistic render would look like if you rendered this particular view. Now remember, this view will change depending on what your eye and target positions are. So I tried to use the same one through all three of these. I am off a little bit on the first one, but it's very close to the other two. The second one looks almost exactly like our luminance calculation. The photorealistic render took 2 hours in the middle, but I set the brightness at 50%, 15%, to correlate to the luminance calculation that I did over on the right. So you can see that this is the exact same view, but it took about 5 hours less to create the view. So it's not ready to be, the 10-hour view that you might want to get with a high setting, but it starts giving you a very good idea of what a nice luminance calculation would look like if we use the luminance option in the program. Now remember, in TracePro, there are two places that we can get a lit appearance type calculation. There's the third tab in the system tree, which is either luminance or radiance, that you can go to, and you can set up a luminance target, and you can specify how many rays per pixel and a view, and render it in that method. That was the old way that we did it. In the new way, with the photorealistic render, we're just getting RGB values. We don't get the exact radiance numbers or the luminance numbers, which you do in the luminance calculation. So the luminance calculation still has its place. If you want to see exact numbers, that's how to get it. But if you want a quicker idea, and one that's probably a lot better for doing scatter, then I would personally use the photorealistic render if I don't need the exact numbers. And once again, this is using an ambient light source from above to illuminate the system. And how I did this was I created a plane up above and had it emit in a Lambertian manner. And that's how this source came into this particular picture. If we look in the left-hand side picture, you can see that source coming in that's brighter at the very tip on the left-hand side and then diffuses out as we come down to the chessboard itself. If you want to have measured results and see how well the measured results are matching up to our simulation results, I have a very nice presentation that was done for us. This is on a power handle for a Dell power server. And the idea behind this was to take a black plastic and replace it with an acrylic, a see-through acrylic, and make it into a light pipe. This is so that when the power server was on, you could walk down a corridor and easily see if it was green, which means it was in a ready state, if it was yellow in a caution state, or if it was in red, a stop state. And so you had 3 LEDs feeding the light pipe. And the results for this particular presentation were given at the Taiwan User Conference in November of 2013. The full presentation in its entirety can be downloaded at the link shown on this page. Dell has asked that the entirety of the presentation be shown and not ever shown in piecemeal. This is why we're presenting it in this method. The presentation is about 2.6 megabytes in size, and it's there for your pleasure to take a look at the capabilities and the measurements. But I can tell you right now that you'll be very well pleased with how well TracePro's photorealistic render simulation matches the hardware measured results. And in fact, it's amazing that in a few hours, from almost any view whatsoever, you can reliably see the results and understand exactly how to design better light pipes using this photorealistic rendering capability. Finally, let's start looking at best methods for doing a photorealistic render. First of all, you want to ray trace as fast as possible, especially when you're doing a high type setting, a render setting. To do this, you want to go into your ray trace menu, select the Ray Trace Options Advanced tab, and you want to set it to fastest ray trace. Since you're doing illumination systems and what the eye can see, I strongly suggest you set a flux threshold of 0.01 in the Flux Threshold tab. You might also want to look at the total intercepts. If you know that light is only going to rattle 25 times at a maximum to reach the exit port of your light pipe, set the total intercepts to 25. That will also speed up your ray trace. Next, we want to set the view size to a very small window size when we start off. I suggest at a maximum 100 pixels by 100 pixels, and make sure you set the render quality to low. Then check the results to get an idea of just how long the photorealistic render will take. If you set to a medium size, understand that if it takes 10 minutes for a render quality set to low, it'll take 100 minutes for a medium render quality. So use the ray trace options to first set the system to ray trace as fast as possible for the photorealistic render. The next thing you want to do is that if you don't like the way the scene looks, it's not bright enough, or if the contrast isn't just right after you've done the render, you can change this. Just go into the Views, Photorealistic Render Options, and change the brightness and contrast post-process. By default, they're set to 50% maximum. After you're satisfied with your low-resolution render, you can set the render quality up higher, and you can set the pixel resolution as desired. So we'll go from the 100 by 100 to, say, 400 by 400. Remember that each higher render setting takes 10 times longer to ray trace, and a view size twice as big will take 4 times longer to ray trace. So for instance, if you select the high render quality setting, each progressive render pass is shown. So you'll see in the system view a new box pop up, and after the low, medium passes finish, you'll be able to see the final figure of the photorealistic render. It will be replaced for each pass by a higher rendering quality. So if you do 3 renders, you will see 3 output, 1 for each one of the passes. Let's take a look at an example that shows how this works in terms of each render quality pass. So if you set the render quality to high, each progressive rendering pass is shown on completion. Let's take an LED that's emitting in a violet wavelength, around 0.4 microns. So the LED emits from the phosphor layer at the top, and I've got an ambient source, which is a plane at 45 degrees above the LED that is also going to show this particular source emitting from itself and as an ambient Lambertian source from above at 45 degrees. The first pass showing the particular LED took 2 minutes, and you can see that on the left-hand side. The medium pass you can see in the middle took 20 minutes, and the high pass took 200 minutes, about 3.5 hours. You can see the progression as we go through each of the passes. You're also seeing the rendering progress below the low and medium passes. You can see that as soon as pass 1 finishes and I get on pass number 2, I can see the output of the low quality pass in the render window. In the medium one, I can see in the middle here, that medium one, and you see it's on pass 3 of 3, which means it's showing the medium render quality figure. And then, of course, after everything is finished, the rendering progress goes away, and all I have is the render output. So it gets much nicer. You can see that the rays fill in as we move from low to high setting. So this is what's going to happen when you set up a render, and hopefully you'll get out the very nice render output that we're seeing here in the high setting and get you what you're figuring out or trying to get to possibly your boss, your marketing people, or for a report. Well, finally, what happens when you don't see anything in your render or see something you don't expect? Well, if you're wondering, when I'm doing a Lightpipe, there's a lot of times where I do a photorealistic render and I don't get what I expect to see. There's a way to use TracePro's reverse ray tracing to go back and see what a target to an eye position would see. And this is using the reverse ray tracing that's available in the analysis section of TracePro. So you're going to want to follow these steps to set up a reverse ray trace. The first thing you need to do is set up eye positions. So you're going to want to create a couple of blocks or cylinders, and you want to position them where you would set your eye. You want to set the target surface to be the exit port of your Lightpipe, for instance. This is where you're going to want to check the luminance at. You're going to want to specify each one of those blocks or cylinders that you set up that are eye positions as exit surface targets in TracePro. You're going to want to create important sampling targets for these exit surfaces because most of the time you're going to have a texture on the exit surface, and you want to have those exit surfaces be important targets to your eye positions. You're then going to want to reverse ray trace. And finally, you're going to work at getting irradiance maps for each one of the exit surfaces, which are your eye positions. So this is a quick way to go back, reverse ray trace, and make sure you are getting light from your target positions to your eye positions. And it's very easy to set up following these 5 steps. So you can verify that if you're having a problem with the photorealistic rendering, is it the reverse ray trace that's causing you the problem? Is it the forward ray trace, which is very simple to do because you're just doing your normal ray trace, or is it something else? So here's the problem resolution I would specify that you might want to do. There's one more thing. We've got everything working in TracePro Photorealistic Render except for file sources at this time. They're currently not supported in the 7.4 release. You can expect this in a future release of TracePro, but it's not in the 7.4 release that we're going to be putting out this week. If you want to use RAW file sources, here's a good procedure for you to use. You're going to export a RAW file to a surface source by using the surface source utility. And once again, there's 5 steps. So the first thing you want to do is define the RAW file source in TracePro. So you're going to want to bring in your file source in whatever format it is, as long as it's TracePro acceptable. And you have 2 options for the second part here. You can put a sphere in front of the source or use the missed rays option to create a candela plot. Once you've set up the sphere or you've selected in the candela options to use missed rays, you just do a candela plot. And what you're going to do is you're going to see a very nice angle over time. And if you want to have an asymmetric plot, or I should say several azimuths, make sure you specify those in the Candela options as well. Once you've got the Candela plot, you can do a screen capture and copy this from the clipboard into the surface source utility. The fifth step is to digitize in the full angular information. You can then add your spectral information if desired, and then export this as a surface source property, and then use that as the definition of your user-defined TracePro source for the photorealistic render. So this is a quick workaround, and yes, you do have to do a little bit of work, but we hope to have this file source capability in a next release of TracePro. Finally, I'm going to open this up to questions and answers. Andy, I hope you can come on here, and I'm starting to look now at the questions.
I am here. Thanks a lot, Dave. Dave, I keep saying Dave. Thanks, Mike. So a lot of the questions in the beginning seem to relate to the fact that nobody could see your screen, so I think we can ignore those. We do have one here. What's Moltec's texture surface? Is it a surface property? I think I interpret that to be.
Yes, we have the Moltec. We have several of the Moltec textures that are available as properties on the Lambda Res website page, and you are able to download this and install this as a custom surface area, surface definition in TracePro, and just select from them and put them on the particular output. And so, for instance, I've done this. Let me bring up TracePro here. I'll bring up TracePro 7.4. And if you go into the Define button, Edit Property Data Surface Property, and we bring up the Moltec catalog, you'll see that I have a few of the Moltec definitions. I'll bring up the 11005 that I used in this particular presentation, and you can see the information for this particular Moltec, which has an RMS roughness and a 3-micron depth. So this is in our properties area in the secure area that you can log into on the website.
And Mike, it might be interesting to back up to just what the Moltec textures are and how somebody might use them. Maybe somebody that's not familiar with the company.
Moltec is the largest distributor of textures that you can put onto molds. They have quite a few. I say they'd have probably 50 different textures that you can apply for different type of operations. Each one of them has a different RMS roughness and a depth that they supply. And you would go to Moltec to get this definition or have them create the mold yourself. Their website is moltec.com. You can go on there and take a look at their particular definitions. Do you want to add anything to that, Dave? Am I supplying enough information?
No, that works for me. I think okay. I think it was just good to back up there for people who might have never heard of Moltec in the past.
Okay.
Excellent. We have a request to see the download link for the Taipei conference paper there.
Yeah, let me bring that back up. When this webinar gets up on the website, which will be tomorrow or late today, I will have this link on this webinar. So you'll be able to just click on the link when you get there.
Great.
And also, if you send sales@lambdares.com a request, I will be glad to send this link to you as well. Also, this PDF will be up as well, so you can have it in either 3 ways.
Okay, so at the moment we don't have any further questions, so I'll put a call out for any new questions anybody might have. You must have explained it so well, Michael.
It's not a very difficult capability inside the program to set up and do one of these. For instance, here's Dave Jacobson's phone booth, which anybody who follows the Doctor Who fame will recognize. And so what you're going to do is, if you want to do a photorealistic render of this particular scene, I have a huge screen. It's 1920 by 1260. That number of pixels is going to take hours to render. Therefore, when I start doing a rendering, or when Dave does a render, this is the size usually of our screen. It's not this huge size that you see here. We usually start with something that looks like this. That's our render. the check, and then we usually just zoom in a little bit. So I'll hit the plus sign here, and so now we zoom it, and then we translate it, and we go, oh, that's a nice looking little render there. And then I always check it. And that's the other thing that I do. I come back, I've got the scene the way I want. I say View, Set View, and I make sure that I have the eye in target position where I want it. And so that's pretty much what's going on.
It would seem we have no more questions, so I think we can wrap things up. I want to thank everybody for attending today. I hope you found it useful and informative, and we hope to see you at our next webinar as well. Thanks.
Thank you.
Thank you. I'll end the webinar now.